Today, I'll introduce Graflow, an orchestration engine designed for production-grade agentic workflows. If you've ever run an LLM agent in production, this will sound familiar. The demo worked. The agent was capable. But once it ran continuously, with retries, partial failures, and human approvals, the system became hard to reason about. State drifted, graphs grew brittle, debugging turned into guesswork. At that point, one thing becomes clear. This isn't an agent problem. It's an orchestration problem. Graflow was built for exactly this situation. Not to replace your agents, but to give them the kind of workflow engine that real production systems require. This slide explains why orchestration has become a central problem. The industry is moving from single AI models to fleets of agents running continuously. As these systems become always on, concerns such as orchestration, observability, and failure semantics quickly become more important than raw model performance. The references from McKinsey, SoftBank, and Y Combinator all point in the same direction. AI systems are expected to operate at scale autonomously, around the clock. At that point, the limiting factor is no longer intelligence itself, but infrastructure and orchestration. This leads us to a key technical challenge. Most existing workflow systems are built around static DAGs. They assume fixed execution paths and a predictable ordering of tasks. Real-world agent systems behave very differently. They branch and loop. They retry when something fails. They pause while waiting for user input. And they make decisions based on model outputs. Static DAGs were simply not designed to support this kind of dynamic, long-running execution. That mismatch leads directly to the next issue. Agentic workflows promise a balance between autonomy and control. They let agents make decisions while still operating within an overall structure. However, when teams try to move these workflows into production, friction quickly appears. Many existing tools introduce steep learning curves, increasingly complex graphs, and workflows that are difficult to debug or evolve over time. The problem is not the agentic approach itself. It's that production concerns, such as reliability, failure handling, and long-running execution, are rarely treated as first-class design goals. Many frameworks expose an agent's internal reasoning loop directly in the workflow graph. This tightly couples orchestration concerns and internal agent behavior. As workflows grow, this coupling leads to graphs that are fragile, noisy, and hard to maintain. Graflow's core insight is simple. Orchestrate agents, not their internal thoughts. In Graflow, each workflow node represents a self-contained agent. Agents own their reasoning, tool usage, and internal state. Graflow focuses only on execution order, data flow, and failure handling. This separation keeps workflows understandable while preserving agent autonomy. Graflow is designed around production requirements. Key capabilities include dynamic task generation, scalable execution across agent fleets, explicit execution and failure policies, checkpoints, human-in-the-loop workflows, observability, and isolated execution. These are not extensions, but core primitives of the system. Workflows are defined using a Pythonic DSL, optimized for readability. At runtime, Graflow executes workflows as a state machine, enabling dynamic branching, loops, and task re-execution. This allows engineers to write clear code without sacrificing runtime flexibility. Graflow scales from local parallel execution to distributed execution using Redis-backed workers. Parallelism is governed by explicit policies such as strict, best effort, quorum-based, and fail fast. This gives engineers precise control over failure semantics in distributed systems. Checkpoints allow workflows to resume from known states, avoiding unnecessary recomputation. Human-in-the-loop support allows workflows to pause, wait for external approval, and resume safely. These patterns are essential for production systems involving review, governance, or deployment. Graflow provides typed channels for sharing state between tasks. Compared to untyped key value approaches, this reduces runtime errors, improves editor and IDE support, behaves consistently in distributed environments. State becomes safer and easier to reason about. Execution isolation is treated as a first-class concern. Tasks can run in process, inside Docker containers, or via custom remote handlers. This is critical when executing LLM-generated code or untrusted dependencies. Isolation improves both security and reproducibility. Graflow automatically traces workflow execution, task boundaries, and LLM calls. Trace context propagates across distributed workers, making agent systems observable and debuggable rather than opaque. This slide summarizes why Graflow is a pragmatic choice for production AI by mapping real-world challenges directly to concrete solutions. Many existing tools expose agent internals in the workflow graph, leading to complex and fragile structures. Graflow avoids this with its fat node design, encapsulating agent logic inside each node. Usability is addressed through a Pythonic DSL combined with state machine execution, keeping workflows readable while remaining dynamic at runtime. For long-running and approval-driven processes, Graflow introduces user-controlled checkpoints and human-in-the-loop execution, allowing workflows to pause and resume safely. Finally, Graflow simplifies scalable parallel execution using Redis-based distributed workers. The key takeaway is that Graflow directly translates common production pain points into clear architectural solutions, making agentic systems easier to build, operate, and scale. To summarize, Graflow provides flexibility for dynamic, real-world workflows, reliability through checkpoints, isolation and observability, and strong developer experience with clean APIs and Python-first design. Graflow treats agentic workflows as production software systems, not experiments. Graflow is Apache 2.0 licensed and currently being evaluated with early users preparing for public release. If you're building agentic systems and care about production readiness, Graflow is designed to support that transition. Stay tuned for the release and follow us if interested. Thank you.